So the final state that we'll talk about this afternoon and get the perspectives is New Jersey. And unfortunately, the contractor and DOT people from New Jersey couldn't be with us in person today. So we're going to have a a recorded presentation by the DOT, and then a live virtual presentation by the contractor. So first, we'll start with the recorded one from the DOT. That's given by Stevenson Gaither, and he is the principal engineer in the asphalt testing labs for New Jersey DOT. And given what's going on with the storm headed up that way and everything, he ended up having to record his presentation, and we appreciate him responding so quickly and being able to record it because he was unable to join us live today. So with that, we'll virtually welcome Stevenson's presence and get the video started. So.
Good afternoon, everybody. My name is Stevenson Gaither. I work at the New Jersey Department of Transportation, Bureau of Materials, Asphalt Testing Labs. And today I will be presenting to you New Jersey's experience with balanced mix designs. I apologize for not being able to be there in person and also not to be live presenting this, but you know, we've had, I think my town had about 8 inches of rain. So you know, I am dealing with a lot of flooding issues at my house. So before I start my presentation, I just wanted to give an acknowledgement to Eileen Sheehy, who is the former manager of the Bureau of Materials. A lot of the work we've done with balanced mix designs, she was heavily involved with it. And also Tom Bennett at Rutgers, you know, and we have some industry partners as well too. I more so came into the picture 5-6 years ago, where I kind of inherited a lot of this stuff. So a lot of the information I'm giving to you today is I got from Tom and Eileen. So primary motivation for us to use balanced mix designs. Our use of balanced mix design started with SuperPave. SuperPave was completely implemented at NJDOT in early 2001. We started seeing some issues with mixes and realized that SuperPave couldn't help with addressing the observed issues with durability. It was decided to take a look at different ways of doing things to get more longevity out of our pavements. NJDOT first, we started using 125 gyration mixes when SuperPave came out. In the late 1990s, we found that the 125 gyration mixes were not working because they were just very low in asphalt content. We then moved to 100 gyration mixes, and a little under 10 years ago, we reduced it again to 75 gyrations for asphalt mixtures, and that's where we pretty much are right now. We do have some L mixes, but we pretty much are at the M level of compaction. After doing all this, we still didn't see a significant improved durability in these mixes. It was then decided to look at performance testing in an attempt to address the observed distresses. We started developing specialty mixes that were engineered for specific applications. Some of the earlier specialty mixes were reverse engineered from proprietary mixes. They were mixes that performed well, so we developed specifications based on performance testing instead of solely volumetric properties. Tom Benner at Rutgers was able to reverse engineer two asphalt mixtures to get the desired performance we were looking for. For example, we like the performance of what a lot of you may know as strata, a reflective crack relief system. Thus, we targeted the strata performance and reverse engineered specs to get what we wanted for our version of that asphalt mixture. That mix is today what we call brick. A similar process we did for BWSC. HBTO, BRBC, high wrap, HRAP are some of the other performance mixes that we also have as well. And each of those has their own specific application. So in summary, our motivations for the use of balanced mix design was because the implementation of SuperPave resulted in drier, coarser mixes. To address the issue, we use lower gyrations and supplemented with performance testing for these specialty mixes to get the level of performance we're looking for. Performance test selected. So early on, there was no effective and quick means to test asphalt mixture for performance. The flexural beam fatigue, SST, IDT were all available, but did not provide an easy and efficient way to test for durability. When the overlay tester came around, that changed things since it can be done on field cores and lab specimens. TTI showed that the overlay tester was sensitive to mixed parameters, which was of importance to us. Today, we have 3 performance tests that we use. The overlay tester, according to NJDOT B10, which is on the bottom left there. The asphalt pavement analyzer, according to AASHTO T340, which is on the bottom right. And then the flexural beam fatigue, AASHTO T321, which is up top there. So the factors in selecting our performance tests that were considered were sensitivity to material parameters, good correlation to field data, testing time, pass-fail tests, and simple analysis of results. The APA and overlay tester met all this criteria. The flexural beam fatigue does not. It does not have a simple analysis of the results, but we don't test a lot of this typically during the season. So we're still able to analyze the result in a timely manner and get it done. So that's why we still use the flexural beam fatigue. Also, we use it on our BDWSC, that's our bridge deck overlay. And we're concerned about when a crack would start. We want to try to resist that crack starting for as long as possible. So a crack initiation test like the flexural beam fatigue is crucial for the performance of that mix. Out of all of those factors, the most important one is good correlation to field data. For the APA, the criteria was set by testing existing pavements that did not have running problems. So in the early 2000s, Rutgers tested a lot of good rut performing pavements and found that they had rutting in the APA at most of 4 millimeters. So it was determined by Eileen at the time that and most likely Tom, that a good performing pavement for the rut parameter would need to have its APA criteria set around 4 millimeters, depending on its application and depth in the pavement for New Jersey. For the overlay tester, the verification of the criteria was not done until the development of the high wrap spec. SPS 5 sections with various pavements containing different wrap contents were tested and validated that the overlay tester was better than the flexural beam fatigue at determining how quickly pavements fail based off of cracking. SPS 5 sections were going out of service, and we got cores out of the sections and correlated overlay tests to those sections. The sections had a combination of wrap and virgin mixes. The overlay tester was found to be a good discriminatory test to how well an asphalt mix can resist cracks. Once a crack starts, it was able to determine how well a mix resisted that cracking and led to its eventual failure. The next few slides kind of show exactly what I am talking about with the overlay tester. So This was on the SPS 5 sections, and this was showing the transverse and alligator cracking. And I'm not sure how well you guys can see it, but there are 4 different mixes, 2 virgin mixes, 1 milled, one not milled, and 2 30% wrap mixes, 1 milled, 1 with no milling. All these sections at about 2 years showed that there was cracking. So with the crack initiation test, like our flexural beam fatigue, it would show that these pavements all perform very similarly. But we already know, based off of our experience, that that is not the case, and that we should see better performance out of the virgin mixes than we do the wrap mixes. So this next slide shows exactly that. If you look at the black line at the bottom, that has the best performance. That's the virgin mix that was milled. And then the next best performing mix as far as cracking goes is the other milled mix, which is the green line. And that's with the other virgin mix with no milling. The two wrap mixes showed alligator cracking almost double or more than double, actually, of the virgin mixes, which would make sense. Now, with that previous slide I showed you, our crack initiation test, like the flexural beam fatigue, would have showed that these pavements perform very similarly. But in fact, looking at this, the cracks actually propagated very differently through these mixes. The overlay tester was also able to pick up these differences in those mixes. So if you look on the left side, the 2 on the left side are the virgin mixes. The left hand side of the left 2 is loose mix. Then we have field cores of virgin mixes, and then we have loose mix and field cores of 30% wrap mixes. And the overlay test results for the loose mix and the field cores way outperformed their counterparts with wrap, which gave us enough confidence to say that, the overlay tester is able to determine different mixes, different cracking in mixes, and it went hand in hand with the previous slide. So now we have test selected. We feel confident about the criteria that was set, and it's time to put this on projects. The first year, there were 2 HEPTO projects, one on I-95 and I-287. Both are interstate roads with high volumes and very high truck traffic. We were having frequent group discussions to discuss and come up with ideas, and Rutgers executed the plan. An important thing is that there was no constraint on methodology. Tom Bennett at Rutgers was very open to things for us and doing things for us without having to wait for the research bureau for a project. This resulted in not a lot of reports, but more so presentations. Going through the research process would have been very expensive and time consuming. The informal structure allowed for creativity and a lot of trust. Partnership with academia and industry with flexibility and limited constraints really attributed to our success in getting these performance mixes out to construction quickly. The idea with using HEPTO on this road was, if it was going to work on the high volume roads, I-295 and 287, if it was going to work that on these roads, it was going to work everywhere else throughout the state. We weren't getting the performance with conventional materials used in that area. So we used our HEPTO mix, which is a thin 1-inch high performance mix with a PG 64E minus 22 binder. It's pretty much a nominal size 4.75 mix. And we decided we would use it here to see if we can get better performance out of this area. we ensured that we had trusted industry partners to work with to make sure this first mix was produced and placed correctly, which I think was very important. If we had some contractors that maybe weren't the best or didn't care for this to really work, then everything could have been completely different with this project. But we made sure we had a contractor that was a well-performing contractor, and they were part of a lot of the discussions we had. We felt we needed to have a certain level of confidence with the supplier and contractor on this project because we were doing it on a high-profile road. We couldn't have done this also without the support, of Rutgers. So for Hepto, the first project ended up being very successful, and I think it was because of a lot of that partnership and just having that trust in one another. For BDWSC, there was one pilot project in Atlantic City because it was a reverse engineered mix, and that was from, I think it was Asphalt 50, I think it was called. We had confidence that it would perform very well. And for brick, it was very similar. We had a project in 2010, and that was, again, reverse engineered from the Strata mix. So we also had confidence that this would also perform. And for our high wrap project, we made sure that we had two control sections. We had a high wrap section, and then we also had a conventional section so we can further measure actual field performance. So here's our mix design approach, balanced mix design approach. I was having some tough time trying to zoom in, but hopefully you guys can see it a little bit. At least the colors is really all you really need to see so you can kind of understand it. So this top part here, the contractor submits a JMF to the DOT. And again, it goes through all the volumetric design, we do gradations, TSRs, things like that. And once they pass all volumetric properties, it comes out of this green part here. And then it now asks this question in this blue part. Did it pass the gradation of volumetric criteria? If no, then again, like a typical mix design, no, they go back to the drawing board and then have to submit everything again. If yes, now they go to performance testing and then submit plugs so we can actually test the performance now. And again, we ask again, did performance pass? If not, it goes all the way back to the drawing board. They have to, modify their mix, submit a new JMF to the DOT, go through volumetric mix design again, and then come back through to performance again. And if it passes, then you get a performance mix that passed. So we're still doing volumetric design, but we're checking it with performance. If performance fails, they're allowed to go back and modify their mix design so they can not only meet volumetrics, gradation of volumetrics, but also performance. So some modifications we made to our mix design criteria for our performance mixes is there is no binder grade specified. So for all our performance mixes, we just say provide a binder that allows the mix to meet the performance criteria, pretty much. And so what we do is once they provide it, and at mix design, they'll provide something, but we're more concerned on when it's time for the test strip. When they provide a certain binder at the test strip, we compare a binder later on during production to that binder that was at the test strip. And we want to make sure that it stays relatively consistent. Another addition is none of our specialty mixes that we run performance on have wrap in them. Wrap, as you can see by that other slide that I showed previously, introducing wrap into the mixes really makes the mixes very brittle, and it does not last in the overlay tester. The next 2 points kind of go hand in hand. We have an increase in AC content in those mixes as well as BMA. and also, which again goes hand in hand, to a decrease in air voids. The design gyrations was probably also came because of just our changes in superpotency and dry mixes. So those last two kind of go hand in hand. So during production, we test all these mixes, but we first start testing it at the mix design, then at the test strip, and then during production. So all those phases, you need to pass performance to be able to, meet our QA standards. For Hepto and that mix, we're doing a lot of. We test it every 3,500 tons. That is what we're calling a performance spot. And that is probably over the course of maybe 2 to 3 days where we're getting a full performance slot, which consists of 11 gyratory samples, which is 6 APA samples and 5 overlay samples typically. Brick, we're doing every 7,000. BWC is one per project, only because we don't have a big tonnage usually with these projects. So typically it's just one sample, and that's pretty much it after the test strip, and that's pretty much it. High wrap is every 3,500 tons, and BRBC is every 3,500 tons. So some impediments for QA testing that I see is that right now, for us to run a full performance on Hepto, let's say, it takes us 2 to 3 days if we have no queue of samples. And we're also, not only do we have a standalone overlay tester, because that's the test that's taking a long time, we also are running overlay tester on our AMPT. APAs are done pretty much in a day. That's a pretty quick test, but the overlays, you have to cut them, bulk them, make sure you're still you got the proper air voids. You have to glue them down and then condition them. So, it's a process. So it takes some time. So that's an issue I see with us going to full performance on other mixes, because we just don't have the time. Also, and wouldn't be able to get the results back in a timely manner. Also, space becomes a very big issue. And just to put it into perspective, I'm sure some other DOTs probably are feeling this as well. We are at capacity with our testing facility. And we're told we can't get another facility. So right now we're currently testing somewhere around 4,500 density cores in the season. And with the way our performance specs are set up now, we have another 5,000 performance gyros in the lab as well too. So just physically keeping these samples somewhere would be a hassle. Personnel is another issue. We have issues with retaining lower level titles because once they get some experience, an opportunity comes up somewhere else, whether it's in DOT or not, they tend to leave. So and the hiring process at DOT is also pretty difficult. It takes us months to get somebody actually hired, so when we lose people, it takes a very long time to backfill. And also, and I'd probably say maybe one of the more important ones is our current operating procedures. Again, as I said, we're at capacity. So if we are going to go for performance, which is the route we want to take, we really do have to take a look at our current testing program and see where can we make cuts, where can we make adjustments, do we have the field test a lot of these performance? It's a lot of questions that we have to ask on just our internal process. So to really go to full QA testing on all our mixes. And with that, that's the end of my presentation. Obviously, I'm not there to answer questions in person, but if I'm sent the questions later on, I can definitely send back my response. So thank you.
All right. And again, thanks to Stevenson for being able to record for us on such short notice and after 8 inches of rain in a property. I can't imagine how fun that is right now. So our last presentation before we get into question and answer will now be the contractor experience for New Jersey. And we have Kai Paulman from Tilcon, New York and New Jersey, a CRH company, joining us virtually. Has 15 years of experience, 6 years of those being at Tilcon. So hopefully have him up.
Okay. Thank you very much. All right. Do we have visual here? Testing 1, 2. Very much. All right. Good afternoon, everybody. Like I said, my name is Kai Qualden. I'm with Tilcon, New York. I'm the quality control director here. And I'll be following up on Stevenson's presentation to give you the contractor perspective from New Jersey. Real quick, I'll make a few acknowledgements. Cindy LaFleur, Rich Linton, as well as Stevenson with the New Jersey DOT helped give me a lot of the background for some of the work that we've done over the years. So thank you for that, as well as all of our QC personnel here at Tilcon who inputted their experience and their perspective on what we've been through. So that's been a huge help. And another point of note, I should say, just before we get started, I am one contractor of many here in the state of New Jersey. So this is a perspective of our own, and hopefully you'll be able to get something useful out of this presentation. But certainly there are other experiences as well that are out there, and getting everyone's perspective on this is certainly crucial for having a successful balanced mix design project. That being said, we'll jump right into it. As Stevenson mentioned earlier, a lot of our mix design, our balanced mix designs are below. We have the high performance thin overlay, the binder rich intermediate and base course, high wrap, as well as the bridge deck mixes. So those will utilize performance testing, including the APA AASHTO T340, as well as the overlay, which files in New Jersey DOT B10. Also, the bending beam was mentioned. A lot of our experiences here at Tilcon involve the APA and the overlay, so that's why I focused on that. But certainly there are others as well. So even with the rutting and the cracking, there are various criteria that each mix has associated with them, but they do all follow these two tests. What balanced mix design brings to New Jersey, at least from the contractor perspective, is I believe it's the opportunity for better performing roads. I think we can all agree that that is a high priority for everybody to put out a good product, to have a longer lasting road out there. So this, I think, brings us to the right place. The balanced mix design also offers the flexibility to optimize production, right? Focusing on the end product with our rutting and our cracking allows us as a producer to focus on how we can improve our processes to optimize our mix. With that, I think that brings a more competitive market, encourages a competitive market, and potentially can reduce costs as well to the agency and the buyer. There's also volumetric flexibility. Again, focusing on the end product, there's the opportunity there to be more flexible and think differently about some of the volumetric criteria that we've had in the past, and encourage more of that out of the box thinking. Some of the obstacles that we've had with balanced mix design and working through this, time is certainly one of them. To complete the performance tests that can lead to delays. There's physically making the samples for the performance testing, as well as having them tested. Now, those just take time. That's a reality. So incorporating that into your project needs to be a consideration. It's also not an ideal situation to have a potential failure when you're halfway through a project that started at the beginning of the project. So, that needs to be part of the process, is working that in. With high wrap mixes, that may slow down production. So that's a consideration. There could be an increased cost associated with the personnel and the testing. Us at TOCON, we send our samples out for testing. So whether or not it's part of the design process or during production, there would be a cost associated with that, certainly, as well as potential personnel needed in order to accommodate the added testing. If there's specialized oils involved, there's storage capacities that need to be considered. Where if you're using a different grade of binder than you normally use, or a specialized binder, you need to know where you're going to put that and coordinate that with your production. There's also the training and knowledge of the personnel and the people working on these projects, so that needs to be developed. And communication, of course, with the agencies regarding their specifications. You may have different agencies in your area working that want different criteria or even different testing altogether. So that all needs to be worked on beforehand, prepared before your project. As far as the design criteria goes, I would suggest certainly exercise good communication between the industry and the agency. I think you'll find a lot of what I'm talking about right now has already been addressed, or it's been brought up before. You'll notice with a lot of the other presenters, this isn't anything new, but a lot of the folks that have done this before have had good communication with each other, a good partnership with the industry and with the agency. So that's key. You want to do some research to establish your baseline data. And what I mean by that is know your mixes before you get into a project. You want to know where you stand with a lot of these performance testing. And you also want to have realistic expectations of what your criteria is going into a project. Certainly, we've been paving roads for a long time, and we want to make sure that our new specification is we're not reinventing the wheel there in some respects. And exercise transparency with results. Share the results between the agency and the producer. That's only going to strengthen our knowledge that we have on our mixes and lead to better performing pavements. As far as the quality control operations go, as I mentioned before, additional samples need to be made, whether or not you're doing it in the design process or you're doing it during production. If it's during production, whatever the sample and testing frequency is, you may need increased personnel in order to physically test those samples. So that needs to be considered. That was a big change, I think, in our operation, what we dealt with. As well as before, communication with the agency, and determining how things are going on the project. Changes to the mix design. A lot of the big changes that we've noticed were the higher binder content, especially several high rack mixes. And of course, just sound like a broken record, but it is the additional testing and our time constraints that. So that does affect our mix design and the process, as well as the different binder types. So different binder types is also a big change in the mix. As Stevenson said, on a lot of these performance or the balanced mix design, there's not a binder requirement. And so that's up to the producer set to figure out what binder works in order to achieve those performance characteristics. When it comes to improving results, our experience has been fast and accurate testing is only going to serve them better. And I think we know that in any case during production. The sooner you have results, the easier it is and better served you are to make changes and adjust if there are any problems or if there are any corrections that need to be made. As I said before, you don't want to have to find out you need to make a large change on a material halfway through a project and your results are coming in from your first day of production, a lot of material on the ground. And I think that's been said before from other folks earlier today. Increasing binder content can increase your performance characteristics. As you'll see on the chart here, I think there's a good illustration between your rep depth and your cracking life. As you increase or decrease binder, it will affect your wetting and your cracking. So there is, of course, a balance there that needs to be achieved. As you increase your binder content, you're going to increase your rep depth and inversely with cracking. So those are ways that you can adjust your mix in order to improve your results. Binder is also key. It is a big driver in not only the percentage of it, but the type of binder is a big driver of your performance. So determining the right binder for the right performance criteria needs to be determined. Avoid asphalt storage tank contamination. That's very important. You don't want to have commingling of materials in your tanks. It is a consideration or a coordination that needs to be made with the production facility because you can't. It will affect your results if a lower grade binder gets mixed in. The storage time of the material, if it's going to be sitting for a long time, that will affect your results, especially if you're getting small quantities of customer, or if you're coming in for a small quantity of the material and it requires a different grade of binder. The material needs to be mixed well, and so if it's sitting in the tank for long periods of time, it tends to separate. Also, rejuvenators, I think has been mentioned before, can be a good tool for improving performance results. But determining the dosage is also critical on that. The impact on field densities, certainly it can improve compaction. As we said before, a lot of these mixes, the binder content has been increased to achieve the performance characteristics. So your conventional mix fundamentals apply there. If you're increasing the binder and where the air voids are reduced, certainly you're going to have an easier time getting compaction or achieving compaction on the job, and which is not a bad thing, right? If you have lower voids in the plant, or that is not a bad thing if you're ultimately, if your cracking and your wetting criteria are met and you're achieving that performance, and you're getting density either faster or just greater densities period, that's only going to make our pavement better. So that's, I think, a win-win. And so I said, expanding the volumetric criteria, I think is kind of a part of us moving towards the balanced mix design and looking at the performance of the things. So looking back, after it's all said and done, what could we have done differently? Our lessons learned over the years, I think, would be plan ahead. It goes a long way, some good planning. If you know what your project is requiring, you can plan for that and you can get your ducks in a row beforehand. It's not the type of thing you want to learn on the job, in my opinion. Split sampling would be a great idea if you're working on a project. Accuracy of testing, of course, is very important, but also if there is a failure, it's great to be able to have that split sample to go back and verify your results. Communication and sharing your information with your agency and vice versa, getting that communication line to go both ways so that you have a better understanding of your mixes is also very important. And I would say more research and participation with agency and association, going into a lot of these, really understanding your mixes and doing the research ahead of time so that, and working with your agency and your association to get that information out there is always good. So in closing, I think the ideal direction for a producer is to focus on that out-of-the-box thinking. As we move towards the performance end of things and we look at our end product, really opening the door to think outside the box and to try new things. If we're focusing on what our end results are, wetting and our cracking, that's what we want to fix. What can we do to achieve that? It can improve our communication. It's always out there. It can always be worked on. So certainly that we want to work on as an industry altogether. We want to know where we're going. As we establish new criteria, new specifications, it's really important, I think, for us as a producer to know where we're going and the direction that we want to go. So, as well as technologies and materials progress, we expand our criteria as well. I think that's absolutely crucial that we keep an open mind as we head into this new era of production or of material, that we not only kind of expand our thinking on what we're doing, but rethink what we've done in the past. It's not to say that that's bad by any means. It's kept us afloat for a long time. But what I would suggest is, not necessarily have your standard conventional mixes and tack on a performance aspect, but rather really focus on a balanced mix design approach, where there is a little bit of give and take on both ends. So with that, I want to thank everyone for their time. And if you have any questions, we'll look forward to answering those in the panel.